Hey everybody, welcome back. Okay, so in the last video we kind of outlined some properties of these parallelograms, and in this video we're going to go ahead and take a look at a proof, and this is called coordinate geometry because they're giving us the coordinates right here, L, M, N, and O, and we're being told to prove that the quadrilateral with the coordinates L, M, N, and O is a parallelogram. All right, now of course we want to graph it probably and take a look at it that way. Then we'll kind of plan our attack from there on this thing. But here's the methods you might want to think about to prove something like this. All right, you can show that the diagonals bisect each other. That's one of our properties. And it says by showing the midpoints of the diagonals are the same. That's one way to do it. All right, or you can show both pairs of opposite sides are parallel by showing they have this equal slopes. Now these are ors. You don't have to do all of these. You choose one of these. Any one of these things will prove this for us. Show both pairs of opposite sides are equal by using distance. Show one pair of sides is both parallel and equal. All right, so let me show you what the graph looks like. So I've taken this thing and stuck it into GeoGebra. And there's what it looks like graphically. All right, so when you look at the graph, then you kind of get, I think, a better sense of what might be the easiest way to go at this thing. All right, so what I've chosen to do with it, and you might have chosen a different bullet point there, go back and check them out, is I said on this one, I think what we'll do is prove as a parallelogram by proving the slopes are opposite sides have the same slopes. Remember, that will prove as a parallelogram. All right, and now just looking at this thing, let's be realistic. This has a slope of 0. It's a horizontal line. So does this one. All right, this has a slope of what? Over 2 up 5. Over 2 up 5. They are the same. Okay, so to be clear, what we're going to do here, what we are going to do to prove this is we're going to show LM is parallel to ON and LO is parallel to MN. Okay, so I've already written my coordinates down where I can see them and I can work with this. And basically we're going to find the slopes of each one. But if you're going to write a proof, this might be a good time for us to practice that anyway. I like to state what we're trying to show first. So I'm going to say we must show. All right, what are we going to show? We're going to show that, like we said, that the slope, or we're going to say LM, line segment LM, is parallel, and you can use those two vertical lines for the word parallel when you work with geometry. And we want to show that it's parallel to ON. But that's not quite enough. We have to show both opposite sides are parallel. So we're going to say and. One more thing we have to do is we have to show MN is parallel to LO. All right, so we'll go to work doing that. And then that's like your first statement. Put a period there. And you'll say, okay, the next thing I need to write, I need to start finding some slopes here. So we'll say that the slope of LM. Now we're just going to compute it really quick here. I think I'm going to get 3 minus 3, that's your y coordinates, and 4 minus negative 2, well, that's actually 0, right? And we'll find the slope of ON next. And if this is getting messy, it's not as easy to write on this thing as it looks. is, what are we going to get for ON? -2 minus -2. Oh, come on. Sorry, I had to go fix that. If you push the button on this pen, somehow it just starts going haywire. So what I've done here is I computed ON on the slope of ON, and I found that it was also 0. All right, so there needs to be another line here where we'll say, so. Now we can state this first part. We can say now, we have shown that this is parallel to this, right? Now the proof goes like this. You need to go back, and now we got to prove the second part right here. We need to prove that as well. All right, so we got our 0 and our 0. That's the first part of this. I'm going to clear this screen, and we'll do the second part. And all right, so our last line there said we have shown that LM was parallel to ON, and now we're going to show that MN is parallel to LO. So let's do that one. All right, the slope of line segment MN is, let's see, all right, what are we going to get? So I'm going to get -2 minus 3 over 2 minus 4. Almost pushed that button just then, which gives me -5 over -2, which is what we already knew it had to be, was 5/2. We block counted. So we already know what we're supposed to get, but we're supposed to be showing this. So we can't just say it looks like it. All right, and then the slope of LO is, all right, be careful here. We got -2 minus 3 again. -2 minus 3, and that's over -4 minus -2, which again is 5/2. All right, so what we've done there is we've basically proved this, but we need to state it at the very end here. And so we write, so we can say now that MN is parallel to LO. And you really need to finish this up by saying, thus the quadrilateral is a rectangle. But I'm kind of out of space, and this video is getting a little long, but that's how it would work. Shorthand would be, they'll use these dots. Now at our level they wouldn't. That means thus. You would say the quadrilateral is a rectangle, and that's the end of that little proof. But more than likely, you guys would run into this in multiple choice, and you just have to be able to spot the technique being correct. To be honest with you, but write these down. Hope that's helpful. The next proof we'll do, we won't use the same method. We did one with slopes there, and that seemed a little long. It might have been easier to just do the midpoint thing, but that's the one I picked. You can pick your own when you do yours. All right. I'll see y'all in the next one. We'll talk rectangles next.